the recording. Okay. So we've got a bit to go through today. We're going to be covering some data structures. These are 3 different data types that are built into Python. We have some sort of some practice for strings and then some more data structure stuff. My goal for today is to just get through the data structures stuff, and I might just assign the string practice stuff for homework, but we'll see how far we get. Okay, so quick overview. Types. Types abstraction, control flow, and iteration. So we've covered a variety of types. I won't go through all the ones because I think you know int and float and all that. Recently we talked about lists. Today's material is going to talk about sets, tuples, and dictionaries. I'm actually going to cover these in the opposite order, and you'll see why. So these are, like lists, all mutable types, meaning that they have methods that can alter their value. So yeah, so that's what's on the slate for today. Just a quick recap. Abstractions we've covered are variables. Yeah, I may have spelled that wrong. We've covered functions. Control flow is just your if, elif, else. And it's condition checking, writing dynamic code, etc. Iteration, we've covered both of the major iteration tools that we're going to use, for and while. I did mention one. We were talking about strings the other day, or excuse me, yesterday. And I mentioned one at the end when we were talking about join. So strings have a method called join. And I mentioned another iterator, and I'll consider this sort of a minor iterator called map. So like I said, for and while are the ones that I want you to focus on utilizing in your own code for the most part. I mean, if you learn map and if you learn comprehensions and there's other iterators, I'm not going to stop you, and we will cover those to some extent. But basically, I'll just cover map really quick just so there's some context for what that was. If I have, and I'll cover it in the context of join because we often see it with join. So a quick recap on join. If we have, let's see, let me grab my little text here. Oops. Okay. So I'm going to dot split this on words, and if I print text, we're going to get a, oops, forgot to execute my code here. Oh, what happened? That's not what I intended. Okay. Okay, so this split function, remember split will break apart a string into its words. If I don't pass an argument to split, it will split on the white space character. Okay. Um, an alternative to this, instead of doing it this way, that might look more familiar, I can just do text like this. This is a big string, and then I might do something like word list equals text dot split, and that'll capture the list that split returns of all the words. Okay, so this is fine. I can do whatever I want to this list. I've got this list of words. I can do whatever I want to it, and then when I'm done, maybe I want to turn it back into a string. I can say join on spaces. So I'll say empty or string with a single space in it. I said empty, but I want to distinguish this from an empty string is a string with no characters in it. This string does have a single space in it. It looks really weird, but it's actually necessary because this space is what's going to be the separator for the elements in the list. So I'll say empty, or I did it again. String with a space in it dot join, and we'll join word list. Of course, I've got kids these days with their print statements. Print it out. Okay, so that turns it back into a string. So this works fine because all of the elements in word list are strings. But let's do this really quick. It's a list, right? Word list is a list, and like a list, I can dot append to the list, and let's say I append a number or something. So now I have a list of strings, and I've just got this integer. Notice this integer does not have quote marks around it. Sorry, that's probably a little small. Let me increase the text size in my terminal. Is that better? Hopefully that's better. I'm going to assume that that's better. Let me pull this out. Oh, that's way big. Okay, that's fine. So I've just got this integer at the end of the string, or excuse me, at the end of the list, and all the other elements are strings. So this is fine. You can do that, and this would apply not only to a list of mixed strings and numbers, but of a list of numbers. If I try to join this, either if the list has anything that's not a string in it, and I try to join it, oops. Oh. Okay, whatever. Terminal's acting a little funky. There we go. Okay. So since I'm trying to join this list, and this list is not comprised only of strings, so when I'm trying to join a list, the list has to be comprised only of strings. If it's not, I'm going to get this error, and it's going to tell me sequence item 30, which is it's the 30th element in the list. Expected stir instance, but int found. So it found an integer where it expected to find a string. So what this is telling you is that join requires that you pass it a list of all strings. Now, there's a few things we could do here. The brute force way, which is, there's no dishonor in code that works, even if it's, clunkier than it needs to be. But so the brute force way would be to do an accumulator. I'll just start an accumulator. List equals empty list, and I'll say for element in word list. We'll iterate through word list, and just to kind of illustrate what I'm talking about, I'll print the type of every element in word list. Oops, that's LST, not LIST. Okay, so I'm printing the type. No, back to string does not exist. Okay. Oh, print the type of word list. I meant to print the type of element. Okay, so if we look, class int, blah, 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 and then at the end, or class string, and then at the very end it says class integer. So this is telling me this is all strings except for the last one, which is an integer, which we knew. But I wanted to do this just to give you some context. Okay, so what I could do is list, which is this list here, that's my accumulator target. I'll say list dot append, and I'll append every element as a string. So I'll say stir element, and this is going to pass the element to the stir function, which will return a string version of it. If it's already a string, it's just going to ignore it. Essentially, it's not going to do anything weird. And then that will convert list to all strings. And if I print, here, I'll just real quick, oops, keep hitting that keyboard shortcut. I'll print off list really quick. And now if we look, this 57 has quote marks around it, which tells me it's a string. So if I go back to here and go back to my join, and I'll pass it LST, which is the list that has all strings. And let me be clear about this. This is all strings list. Now it works, and we've got that 57 in there. And it worked because 57 is a string. So when I was using map, what I was doing in essence was saving myself having to write these 3 lines of code. If you look at this, all this does is generates a list with the string function applied to every element from another list. So it's whatever the stir function returns in a new list. So it's just sort of a transform from word list to all strings list, right? And I'm just converting everything to a string from word list. So that's a common enough description of a number of kinds of problems that there's a built-in function called map. So I want to map the stir function to every element in word list, like that. And that's what that's saying. And that saves me from having to do all that there. So again, if this makes sense, hopefully this makes sense. If not, just know that map is replacing the need for a for loop. Map will make sense eventually. I know for me it took a while. So if it makes sense, that's great. If not, you won't need to know it really to get through our material. Since we're teaching for loops, you can just use for loops. But one day, of course, it will be useful to know map, and this will give you sort of a foundation for later. Okay, cool. So that's a good little recap, and let's just dive into... also, if there's any questions, feel free to pop them in Slack, and I'll do my best to answer them. All right, let's dive into the material. Sets, tuples, and dictionaries. So of these, dictionaries, I'm just gonna say it, are the most important of the 3 that we're gonna talk about. So there are, and this is my opinion, and it's relative to the way that I teach this course, but at least when you're starting out, we can kind of push tuples and sets aside a little bit. All the other types that we've covered, int, float, bool, none, string, tuples actually belong up here. Tuples are immutable. And I'll just put a, oops, gosh, I keep doing that, sorry. I'll put an asterisk next to these ones. So all the ones without an asterisk, I'm going to call like major types. Major in the sense that they are sort of your, they're good for daily use, let's say. They're the things that that are like really important to know. So tuples, and it's not that the other ones aren't important, it's just that, well, we'll see. So tuples are a lot like lists. They are essentially lists that are immutable. So they have the features of immutable types and that they are immutable. They lack the mutable methods. We'll see that makes them sound like they're less powerful, but hopefully I'll show that tuples are basically capable of doing all the things that lists are. They just do it in a different way, and we'll talk about that in a second. But the important thing is lists are, in terms of what each one is capable of and the jobs that they're used for, you really only need to know one. If you know one, you should know lists. So there's enough overlap between these that you don't need to necessarily dive super deep into tuples and do everything with tuples or something. But yeah, so that's why I consider that a bit of a minor type, because there's somewhat of a lot of redundancy with lists. Dictionaries are different enough, and they fill a different enough niche that I consider them one of the major types. Sets are sort of the furthest outlier of any of the other types, of any of the other collection types. With these three, with tuples, lists, and dictionaries, there's a lot of overlap in terms of most list problems. You could probably use the dictionary. A lot of dictionary problems, you could probably use a list or a tuple or whatever. So choosing a data structure is sort of at your discretion. It's just whichever one you think you want to use or you think best suits the problem. But you might be able to rewrite the solution using one or the other, and it would be a little different, and there might be an argument to do it one way or the other. But it's more or less up to you, basically. Sets, the use case for sets is pretty far out of scope of the use case of these other three. And the way I think about sets is that they have a very niche use case. So I'll come back around to this, but I don't tend to use sets in accumulators. Occasionally I have. It's really rare. I don't tend to use sets directly. What I'll tend to do is I'll either have a list or a tuple or something, and I'll cast it as a set when I need it to be, when I need to do a set operation, and then I'll get rid of the set, and then I'm left back with my original data structure. So that's what we're going to cover today. So of these types, the types that we've covered, I think it's safe to say lists kind of have the most moving parts of the types that we've covered. Dictionaries are a little more complicated than lists. There's a little more going on, and we'll see that there. So kind of prepare yourself. Dictionaries can feel a little weighty. I don't think it would be correct to say that they're like wildly complicated, but there's maybe more moving parts to dictionaries than other types. So let's jump into those. So dictionaries contain key value pairs in a mutable, unordered collection. Keys must be immutable and unique. Dictionaries are declared using curly brackets or the dict constructor function. And this is an example of the syntax. So I'll explain what all that means, and we'll look at creating a dictionary here. So when it says, let's just deconstruct this first part, right? Dictionaries contain key value pairs in mutable unordered collection. So key value pairs is one idea, mutable is another, unordered unordered collection. So we know it's a collection, so that's kind of redundant. Mutable. I I spent a good amount of time on this, so I won't re-explain it again. But basically, it's just that the data type itself has the capacity to have its value manipulated without reassigning a different version to the variable that references it, right? So what it means is that you can change the value kind of internally in the computer's memory rather than the value being static and then getting different versions of that value and working with those different versions. So that's what mutable means. We've explored that concept with lists. Key value pairs. So key value pairs and unordered kind of go together, and I'll just do this. We've kind of checked off mutable. So key value pairs, keys are the replacement for indices. So dictionaries are a collection like a list, but they don't have indices that reference the elements within them. Whereas if we have a list, 4, 5, 6, well, let's do this, 44, 55, 66. Okay. Oops. If I have a list, all I need to, oh gosh, I keep hitting the scroll, sorry. All I need to do is just put in whatever elements I have in my list, and the index is just automatically there for me, right? I don't need to tell it, well, 66 is at index 2. I mean, I kind of am telling it that, but I'm telling it that by literally just putting 66 here, and then if I put in another number, automatically that's going to be at index 3, right? So we've got 44 at 0, 1, 2, 3. So that kind of seems almost too obvious, like, yeah, of course, it's just going to count up to see its position starting from 0, and we don't need to do anything to manage that. So this is nice because it's just automatically there, but what if we wanted to reference that each piece of data with like a label? Maybe we wanted, what would be a good example here? Imagine I was describing a car or something. I always do this example. If I was describing a car, I might say the make is a Toyota, and the model is a Highlander. Just doing my car here. And the color is black. And the year is 2011. So this is great, but this doesn't actually associate, internally, this doesn't associate Toyota with the make. It doesn't associate Highlander with the model, right? It's just, I have to remember the labels that go with each of these, so if this was car 1, and let's say I had car 2, right, and I could fill this in, but each time I have to remember that there's a label that isn't represented here, and that label would correspond with an index, right? So I would have to say, if I wanted the color of the car, if I wanted to know the color of car 1, I would have to remember that color is stored at index 0, 1, 2, right? So it would be kind of nicer if I could just say color, right? And this is what dictionaries allow us to do. They allow us to label the data with our own terms. So, Toyota is the make would be Toyota. Okay, there we go. Toyota model. I don't know if it's EL or LE. I apologize. My spelling is terrible. Color and year. And why is year a string, you might ask? The answer is, I don't know. It probably should be a number. Cool. So this is a dictionary. Now I'm spreading it across multiple lines. This is a convention. This is not necessary. You don't need to do this. But if I put it on one line, it's kind of a big blob. It's kind of a beast. It's hard to tell what each key value pair is. They all just kind of look like elements without like parsing your eye through each of them. So it's common to see them spread across multiple lines in some way. And this is the way that I usually do it. Okay, so now this will allow me to access an element by the label that I give it. And that label is called the key, right? So if we look at this, these are each key value pairs, right? So make is the key. It fills the role of the index. That's really its job, is it replaces the index. And you might think, oh, well, it replaces it, but maybe there's also an index. Dictionaries do not have an index. They have keys instead of indices. So our key is make, and the value at that key is Toyota, right? Here our key is year, and the value at that key is 2011. Oops, that was invalid syntax. So if I wanted to know the year, obviously I can just put car sub year, car 1 sub year, 2011. Now notice here, when I declare a dictionary, I use curly brackets. But when I ask for the key, right, I use square brackets, just like if this was a list, and I was doing index 3 or whatever. If this were a list, I'd use square brackets and then select my index. But even though this is a dictionary, I still use square brackets to do the subscripting. Even though dictionaries are declared with curly brackets like this. So that can be a little weird. If you try to use curly brackets here, unfortunately it'll yell at you. So it'll say invalid syntax, just like that. So we got to use square brackets. Any questions thus far? Okay. Feel free, if you've got a question, feel free to put it in there and I'll take it. Cool. All right, so this will allow me, obviously I can change the key, ask for whatever value that I want. So a quick note on this: the keys themselves can be any immutable type. The reason for this is that dictionary keys undergo what's called a hashing process, and this may be something that some of you are familiar with. I won't get it. We don't need to deeply understand hashing processes right now, but to summarize, a hashing algorithm takes in some input and produces a unique number for that input, a unique hash value for that input. So the idea is that each value will have its own unique number associated with it, right? So make is always going to have its own unique value, and model, whatever. So what that means is that if I tried to have two keys of the same, two of the same key, since these both hash to the same value, one will override the other. And if I try to do this here, apologies, let me print out the whole dictionary here. Let's do the whole thing. If I try to print out the whole thing, you can see that the last key actually takes precedence here. Let's see, we've got a question. When it says that dictionaries are unique, does that refer to each key being unique, or each value pair should be unique? So actually, happily, that's basically exactly what I'm talking about. So I'm trying to relate it back actually to that exact concept. So unique values, where does it say that? Keys must be immutable and unique. So dictionaries contain unique key values. So since they're hashed, it means that there can only be one of every key, of a given key. We can't have a duplicate of the same key, since it stores the keys in a hashed format. So if you try to have like two of the same key, you may wind up with unexpected behavior. In this case, actually, this is, oh no, that's because, yeah, okay, it's because I did it that way. So if I change the order around here, it's going to just go with whatever the last value at that key was when I assigned it. Yeah. All right. So key value pairs, keys are unique. Okay. So because I want to touch on the unordered aspect, this has to do with basically the lack of indices. The way that hash lookups work, in the way that, just the nature of having keys instead of indices, that doesn't, having an indexed type implies that the type retains the order of the elements. If it doesn't, then it's kind of, why have an index, right? So if you don't have an index, it kind of means that you don't think of the data as having an order. Now, if you observe this, if you've been paying attention, and I've been running this a few times to see if we can get a different order, or to kind of make this clear, it's always going to be printing out in the same order, but that's sort of at Python's discretion. This is not really, you don't think about this as something you can count on, right? Even though this happens to be what I put in here, it's not something that you rely on to have, for dictionaries to have order. So the order may or may not be different during iteration, depends on the implementation of Python, how recent it is, and a number of other factors, whether how the order will be treated in a dictionary. So it's essentially, it's not, you don't think about it as being retained in the same way that you would a list. Cool. Yeah. We've got another question here. Is that value unique to the dictionary, or are all dictionaries in the same program? Are you saying like this whole value between 51 and 54, or sorry, I'm not quite catching on to what you mean. Okay. Um, if you have 3 dictionaries, do you have to avoid reusing keys? Ah, that's a good question. Different dictionaries can have they're let's say they're independent of each other. So they, if I have if I could make another like a car 2 dictionary that has all the same keys, and here let's print car 1 up here, and again let's just do Honda um, uh, um, okay, cool. So um, you can see, so these 2 dictionaries, they are their own independent objects, and will not interfere with each other anyway in any way, right? So just to prove that, let's print car 1 again down here, just to prove that car 2 didn't somehow overwrite car 1, and we'll see that we have the car 1 dictionary up here, we have the car 2 dictionary, and then we have the car 1 dictionary again, and that proves that car 2 didn't like overwrite the same dictionary. So that's actually a really good question, right? So one dictionary has to have unique keys, but another dictionary can have the same keys as some other dictionary. Does that help? Let me know if that answered your question. You can. Awesome. Cool. You can use make and model in another dictionary. Oh, okay, cool. Being unordered doesn't mean that we can't access dictionaries through indexing, right? Or iterate through the values like we do with lists. This is a good question. So being unordered does actually mean that we can't access values with indexing. So I'm just I'll delete, or I'll just comment out car 2 here, so we're just working on one thing. A little bit of a clean slate. So let's look at model. If this were a list or an ordered type, model would be at index 1. Oops. But this is going to be a key error in this dictionary. And this is it's kind of weird. I wish they would put like any copy. Like Python errors are generally pretty descriptive. They're a little dense, but once you get the feel for reading them, they're generally pretty descriptive. Key errors are just like key error, and it just tells you the key that it tried to find in the dictionary and didn't find in the dictionary. So integers are immutable, therefore they are valid. They are valid potential keys. You could use integers as keys. If I wanted to, just to be kind of ridiculous here, let's just make all these keys integers. 539 7 00001. That's just going to be 1. I don't know why I did that. Let's do that. And then this, whatever. So these are valid keys. I don't know why you'd necessarily use these numbers. This doesn't seem reasonable to do this, but it is fair game. So if I had one of these keys that was called, or actually, let's just call this one 1. Then I could do car1 sub 1, but that's going to be black. You know what I mean? So I could use an integer as a key, because it's immutable, but I have done that in certain circumstances, like where maybe the key is a count of something, and then the value is like the thing being counted. Usually you do it the other way around, where you'd have the thing being counted as the key, and then the value being something else, or the value being the thing, the count of the thing. But you could do it either way. So it does, to the first part of your question, being unordered does mean actually quite specifically that we can't access elements via a numbered index. But instead of an index, we have the key. And you could think about this as, if it helps to call this an index, to think of make as an index, then sure. But the proper term is key. So you could think about it this like, give me the value at the make index, but you're really talking about the make key. Being unordered, okay. And there was another aspect. Okay, so the other part of the question was iterating through dictionaries, which brings me basically to the next thing that I want to talk about, which is iterating through dictionaries. So it's kind of funny, if it doesn't have an order, it does raise serious questions and legitimate questions about, can we iterate through it? What does it mean to iterate through something that doesn't have an order? Well, you can iterate through it. You just don't think about the iteration process as happening in a guaranteed order. Now, like I said, every time we've printed this dictionary out, let's just try it out again. Every time we've printed this dictionary out here, it has come back in the order that we put the elements in. And to my knowledge, Python will actually retain the order of dictionaries in terms of the order that you put elements into the dictionary. And we'll talk about how to do that in a second here too. But it does that's a very recent development, and I don't think it's even standard across all different interpreters. It's I think standard in IPython, which is what I'm using, but I don't even think you can count on that being the case in every implementation of every Python interpreter. Either way, whether or not there's some order that's obeyed, you don't think about it as being ordered. Even if it appears to be ordered, you don't think about it that way. So let's just look. When we iterate through a dictionary, we can do for k in. I'm just going to call this. I'm actually just going to call this D for now. D is like my generic go-to name for a dictionary that I don't know what to call. Yeah, okay. So for K in D. And K, you might have guessed, is key. Let's just call it key. So for key in D, let's just print the key. So you might say, oh, great. That's great. Well, what happened to the value? It's not in there, right? So this is kind of funny. If you iterate directly through a dictionary, it's gonna give you back the key. Now the nice thing about this is, well, you get the key, and you can recover the value. Let's call this val equals I'll put it to you. What would I put on the right side of this equals to get the value from the dictionary? And I'll print the val here just to prove that we did it. Does somebody know? Cool. Yeah, there you go. Um, as typed d sub key like this. I will pick this nit because Python will pick this nit. Capital D is not defined, so lowercase d. But yes, the answer is yes. Nicely done. Yeah, you got it. Cool. So the value is going to be d sub key. Right. So we can do that. This is a simple way of iterating through a dictionary. The better way of iterating through a dictionary is there's a method for dictionaries which is .items. ITEMS, and it has parentheses after it since it's a method. So items doesn't cause a mutation, it just gives back the keys and values in pairs. And what it's usually used for iteration like this, not always, but if you recall when we talked about enumerate and zip, that those both let us name multiple things in our for loop like this. For k, comma, v in d.items, and this is going to give us access to k and v. So if I print k, comma, v. So that's really the right way to do it. That's really the better way to do it. And now if we look again, this is actually coming out in the order that I put the elements in. So this behavior is consistent with, in my experience, with recent versions of IPython. And I think there's good reasons for that. I think as time goes on, that behavior will standardize across other interpreters. But I'm sure we'll never call dictionaries an ordered type. And that's because they don't have indices, and it's because we just kind of think about them as a pool of elements with hashed keys that we can reference. So cool. And I think I got those aspects of your question, but if you have any lingering aspects of the question that I didn't ask, feel free to just remind me or let me know. Okay, so let's go through a little acronym. So this, you can apply this CRUD, C-R-U-D. You can apply this for any type that's like a collection of items. If you have familiarity with full stack development, I learned this in my training as a full stack developer. This is sort of lifted from a slightly different domain. This is more from like building web apps with a database backend. A CRUD app is thought of as just like a complete, a minimal or complete-ish style app. So CRUD stands for create, read, update, delete. So let's look at how to do that for dictionaries. We can apply that idea to dictionaries. So how to create? So we can answer each one of these in kind of a couple different ways. Create. So we'll do create. How do we create a dictionary? So I could say D equals an empty dictionary, just like this. Print D. That'll give me an empty dictionary. So this is how I can create a dictionary. Obviously, as I demonstrated above, if I wanted to put things in it, I could put things or some. Let's do some key. I can have spaces actually because it's a string. Some key, and then just some value, right? So this is when I initialize the dictionary, I can initialize it with key value pairs inside of it. Veil. Yeah, left out the U. Okay, some value. So gosh, Oh my gosh. Okay, I am really I'm missing some keystrokes. Okay, there we go. So yeah, let's just get rid of these though. I'm just gonna do the car dictionary. No, I'll create it. That's what I'll do. Okay, so let's say I wanted to recreate the car dictionary. Um, I can add in elements. So now I've got an empty dictionary, so I can add in elements. Remember, with a list, you can append to it. Um, the way I like to add in elements with a dictionary, the way I like to teach it is it looks different, but it has a very similar effect. And it's a mutable operation. So I'll say D sub, let's say make equals Toyota. Oops. I was like, why is it still empty? But I was printing out on the line above. Okay, so if I print it out, then I have a new key value pair in there, right? So even though make is not a key, I can say d sub make and then assign a value to it with the assignment operator. So this is supported. If I just tried to, I'll just comment that out right there. If I just tried to access that key that doesn't exist in there, I'll get a key error and it just says make. And this is, maybe what this should say is make is not a key in D. Something like that. But it just tells you that, and you have to infer that it's saying make is not a key in the dictionary. It didn't know how to access it. So, but I can assign to it like that. So this is equivalent. I don't think that's how that's spelled. Equal to an append. So this is sort of your replacement for an append with a dictionary. Is D sub key equals value. And this brings something up. We can't have a key in a dictionary that does not have a value. You could have a value of none, or maybe something neutralish like 0 or an empty list or an empty string or something. That's all fair game, but it can't have no value, right? A value of none is a value of none. It's not no value, even though sometimes it's referred to that way. But that's technically a little incorrect. So likewise, we can't have a value that doesn't correspond with a key. There's no schema for that. That's just not something that dictionaries allow you to do. Okay, so that's how we can create. So create covers how do we create an empty dictionary, how do we create a dictionary with elements in it, and maybe I'll do make here. Oops. And we could do model. And then how do we create new key value pairs, right? Read we've already gone over. Read does not necessarily mean print, it just means access. So read would be D sub and then some key that already exists. So make, right? Yeah, so that's going to read out the value. It's going to access the value. And read should probably be called access. So that would be CAUD, but you kind of lose the nice acronym there. So read, we'll just say read/access. Okay. And I could access model as well. I've gone over the key errors. If I try to access some key that's not in there, I'm gonna get an error. It's gonna say key error foo, right? Thanks Python for the very descriptive error. Okay. Obviously, I could print these out, or maybe not obviously, but I could print them out. Cool. So that's your read. Update. Well, we could update the. Let's update the model. And there is actually a dictionary method called update, but I'm not going to get into that right now. You can go read about it if you want. It's kind of like an append, but it's a little confusing. It's not really like an append. Some people will say it's the replacement for append, but if you go look at code, I tend to see this more instead of the dot update method. It's more intuitive to do things this way. So I don't teach the dot update method because I find that it kind of gets conflated with other ideas. But you can go read about it if you want. So updating would be updating a value that already exists. So if I did d sub model equals Huntsman. Okay, so then if I print D, so you can see Toyota Huntsman. So that's an update. And then delete. There is a keyword del that just deletes anything you want to delete. So I can delete the whole dictionary, and I can prove that this dictionary is deleted by printing off D and getting a name error, which will tell us D is not defined. So this isn't necessarily specific to dictionaries. This del will delete any variable. It just deletes the variable and the value at that variable. Obviously, you could recreate it. It doesn't make it go away forever to never be used again, but it deletes it to that point, right? So it makes it no longer exist in the program memory. So that gives me, this is the same name error as if it never existed. Like Python's like, I have no idea what you're talking about. There's nothing in the program memory called D to be accessed. So that's del. We can also use del to delete a specific key value pair. So there we go. So if I del d sub model, then I just have Toyota left. Make Toyota. There's also a pop method with dictionaries. I'll print D just to prove that there's both of these things in here. D dot pop. What's pop gonna do? Yeah. So pop with a dictionary does require an argument, which is gonna be. Let's just pop off the make. And like it does for lists, it returns the value at the location, right? So a key sort of describes a location in the dictionary, right? It's like saying give me the value at this location, and an index describes a location in a list, right? So pop returns the value at that location, so it doesn't return make colon Toyota, it just returns Toyota. So I can actually print off pop here, and we'll see that prints off Toyota. Cool. All right. I know that's a lot to get through. Let's take about a 5-minute break. Let's reconvene at 15 after the hour. I'll I'll just take this question real quick. When I read the when I read the dictionary, there is no output to my terminal unless I print. Yes, that is correct. There will not be output unless you print it. So if I do this, since there's no prints in scope here, there's no output to my terminal either. So that's the expected behavior. I just presented it that way because I didn't want to conflate printing with reading or accessing, right? You know, this is still accessing that value. We're just not doing anything with it, and it's not visible on the terminal. So, anyways, cool. 5 minutes. Let's see. I'll take this question. Are you here or are you taking a break? Okay. Is there something like len to get the length of a dictionary, or rather the number of elements in a dictionary? No, I don't remember. I think I'm like 90% sure len just works. Let's check it out. Yep, len. I guess I don't use it that much. So I didn't remember. I was like, I think len just works. So cool. All right. Cool. We can get going again. We've got a few more things I want to cover about dictionaries, and then we're going to jump into tuples, spend most of the rest of the time there, and then we'll talk about sets sort of at the end. So I have my dictionary. We just have the car dictionary again. Something that I forgot to mention for this should go with read here. I keep forgetting to mention this. There's a method called .get that's worth knowing. If I try to access, let's say I have, we'll ignore those for now. Let's say I have, oops, is this? Shoot, where? I didn't mean to cut that. Let's do this. Oh no, that is, okay, sorry. Print D. Apologies. Okay, so we've got, at this stage, right here, we've got D with these two keys in it, make and mod. So let's say I have some problem where I have something equal to some key, and I'm not sure if this key is a member of the dictionary, but if it is, I want to access the value at that key, right? So if I print D sub something, I'm going to get a key error because we know something or some key is not a member of this dictionary, right? So in order to get around this, I could say if something is, or if something in D. And this gets into a test for membership here, which is one of the things that I wanted to cover. So test for membership, if you'll recall, if I had a list of, I could do 33 in my list, and this expression gives me back true or false as to whether the element that I'm checking for is a member of this list, right? Obviously this is going to be false. 55 in list is going to be true, right? So we can do something similar with dictionaries. If I check the dictionary like this, it's going to check the keys, right? So if I wanted to check if it's a member of the values, I'd have to do .values. Oh my gosh, there we go. I can't find my parentheses. Okay. I'd have to do that. But in this case, I want to do keys, so I'm actually going to use the .keys method like this. So if something in d.keys, then print d sub something, else print, let's say something. I hate calling this something. That like makes it feel confusing. Let's call it some var. That's better. So some var, else print some var is not in the dictionary. Right, so this will print some var is not in dictionary. Right, so I could do all this, or I could use the .get method, and that'll save me all that. So the .get method, I could do d.get some var, comma, and I'll just wrap this up in an f string like this. Oops. Like that. Okay, so .get is going to do everything in here, basically. If the key is a member of the dictionary, it's going to give me back the value. If it's not, then it's going to give me back whatever alternative, whatever the second argument that I passed to get is, right? So let's just call this res for result, and we'll print res. And I could just print off this whole thing, but I'm just trying to change it up a little bit, right? So it says some key is not in the dictionary. That's some key is the key value there. If I made this like make, then I'd get Toyota, right? So .get is definitely worth knowing. So this is a good little experiment because we got to cover, we got to check off, I think most of what else I wanted to cover, which was checking tests for membership, right? So again, just to reiterate this, the default behavior, if I test for membership in a dictionary with this if here, is that it's going to check the keys. If I don't specify something, it's going to check the keys. I always like to put in .keys because, you know, explicit is better than implicit, and you know, part of writing good code is being clear, even if it isn't necessary for the code. You know, it's useful for us as programmers and as other people who are going to read your code. So I always like to do that. You know, it's sort of a personal best practice, but it's not necessary. I think typically what you'll see is, oh gosh, I lost it. There we go. Typically what you'll see, checks for membership in dictionaries without the keys behind it, but I'll usually try to remember to put it on there just to be clear that that's what I'm doing. I intend to check keys. And then if you want to check values, you have to do that. Say .values. We already looked at .items for iterating. We could iterate through just the keys with just the dictionary, or we could do d.keys. We could iterate through just the values with d.values in a loop like that. Oops. Oh my gosh. So that's check for membership. That's the keys and values methods. Items we covered. And the .get method. Cool. So all that's left is copy. So we looked at copy with lists, and if you understood why we would use copy with a list, it's the same with a dictionary. I'll go through a quick example here. We got a quick question here. Is some var now the key that used to be called make? Sorry. Yes, it is. The key formerly known as make. So up here on line 85 here, I set the value of some var to be make, so that when I do d.get some var, I'm doing d.get make, and that's going to give me Toyota back rather than the alternate return for get. Does that help? Cool. Okay. So copy. So imagine I've got my dictionary here, which is easy to imagine because I do. And I want to write a function that takes in the dictionary, and let's see, what would I do with it? Let's say I want to remove any key that has a string that's less than 5 characters. So I'll remove characters, remove short strings, and I'll take in a dictionary, and I'll take in a string limit. I'm just going to call it strlim. And what else do I need? Yeah, that's it. A string limit there. Pass for now. Okay, oops. Print remove short strings. We'll pass it D, and we'll pass it 5. So we're going to remove all key value pairs where the key is less than 5. And this says short strings. I should call this short keys, actually. Okay, so if I just for k v in d dot items, if len of k is greater than or equal to stir lem, and I should call this key lem, actually, key limit, del, ooh, I painted myself into a corner because I actually need to use .copy here. Well, actually, no, so here's two, I'm accidentally showcasing two different reasons to use .copy. So let's see why I need to use it for this one. So I'm going to delete d sub k. So if the length of the key is less than or equal to the key limit, then I'm going to delete the key in the dictionary. And then I'm going to return D. Let's say this. So we're going to get an error. This is an interesting one. When I was just trying to think of a random problem, I didn't think of this one. So runtime error. Dictionary changed size during iteration. So what this is saying is this error occurs when you are iterating through an object and you're specifically shrinking the size of that object as you're iterating through it. I won't go through, just for the sake of time, I won't go through exactly why that's a problem, but think through the process. Imagine you have a list or a dictionary with several elements and you delete some element at one iteration. Ask the question, what is or what should be the next your elements, your key value in this case, in the next iteration? Should it be what it was going to be before you deleted it, or should it be what is now the next item? It makes things so confusing that really the better thing to do is for Python to throw an error and be like, yeah, don't do that. Also, it's really hard to manage in the memory. So like there are memory management issues just in implementing. If you made a decision on what the best behavior should be, which your guess is as good as mine for that, implementing that could have really weird consequences and potentially memory unsafe issues. So Python being a memory safe language, it's just like, yeah, I'm just going to stop you from doing that. So that's why we get this error. We can't shrink the size of, we can't shrink the thing that we're iterating through as we're iterating through it. That's what's happening here. So in order to get around this, I could iterate through a copy. So this is one use for copy. Okay, so I could iterate through a copy, and then I could remove from the other one. Okay, so now I have this system where I take in this dictionary, and let's rename this just to be clear that this is, the sameness that's occurring is not the sameness based on the name. So D, let's just call it some dictionary, some D. Okay. Let's see, less than or equal to 5. Oh, let's just do 4. That's all the keys. Okay, so notice this is going to remove make and year, and I'm just going to be left with model and color. We got a quick question here. question is 4kv in D. Is this the same as 4kv in D dot items? 4kv in D will actually give you an error. If you iterate through D without items, you're not going to get V. You're only going to get K. You're only going to get the keys. So if you could do 4K or 4 key in D, and then you could use that key to recover the value. But if you want to iterate through both at the same time, like and do 4kv, which is the standard practice, you have to use dot items like this. And in this case, I actually don't need to because I'm not using V, but I'm doing it anyways because it feels unnatural to not use dot items, honestly. I've written it this way so many times. So, okay. That's a good question. So let's look at this real quick. I take in the dictionary. I iterate through a copy of that dictionary. And then I mutate by deletion. I delete any key value pair whose key is less than the limit that I set from the input. So the question is, what's the value of sum D? You are welcome. And ask yourselves, this is a test of your intuition. And I like to do this. It's always good to test your intuition because, like, once you see the answer, your brain is biased to assume that you always knew that it would be that answer. And this isn't to, like, put you in your place and, like, humiliate you or something. It's but it can be humbling sometimes. Make an assessment of what you think it's going to be. This is partly to get you in the mode of scientific thinking. So anytime you look at part of your code and you're like, I'm not sure what the behavior is gonna be here, take a guess, and it's fine if you're wrong. I am not familiar with every conceivable facet of Python. There's something, like I kind of forgot that len applied to dictionaries because I don't end up using it that much, but I had to test it out. So before you do something, just make a guess first, and just take note of your guess. And go ahead and put that guess in Slack if you feel comfortable sharing. Okay, we've got one for the dictionary will be mutated. Anyone else? Anyone agree or disagree? I know I'm being very leading in my setup to this question. Like just from the whole setup of this question, you could probably infer what I think. But yeah, again, it's just a test of your intuition. Dictionary is not mutated. Say no mutation. Cool. Yeah, so in this case, the dictionary is mutated. So notice it returns that dictionary, but we don't even need to return it, right? Because it's just going to alter the dictionary that we passed in. So again, and I showed something similar, and I did something, where I asked for your intuition on this with lists. I did something similar with lists to show that it's possible to create an object, pass that object to a function, and then internally in that function can cause a mutation that is reflected in the object passed to the function. So we create a dictionary, we give it to the function changes the dictionary. This is undesirable behavior. It is possible in Python. If I were writing the language, I probably would have said, no, don't do that. Maybe I would have made that an error. This is my opinion, though. There are potentially good reasons to break that rule, although that's not something you all should be concerned about for a long, long time. And it's something that I have always found a way to be able to avoid. So there's no case in which I've ever found this necessary. And there are many cases where, back a long time ago, more when I was learning to code, I wrote code that had this kind of behavior in it, and it was nightmarishly difficult to maintain. It was so hard. So if you do this, you're working against yourself to a big extent. So what's the solution? The solution is when you have, and this is one of the big reasons why you want to keep track of which types are mutable and which types are not. For the types that are immutable, if you pass them to functions, they all have a .copy method. So d.copy. So this returns a copy. It gives back a copy. If I printed this out, it would have the same, the same elements and everything. It would just have a different ID. It would be a different object in memory. So the way that I like to do it is just to overwrite this with the copy. Now, this just overwrites this identifier D locally to this function. That's all it does. This assignment doesn't reflect back to this. It just overwrites this identifier, the parameter name, which is the identifier D. So I'm going to take in D. Immediately, I'm going to say D equals D.copy. In this particular case, I think I'll call this dcopy. And then I'll iterate, just so I don't have 3 of the same object in memory. I will reuse the original object, and I'll iterate through the original object. Now, this is perfectly safe to do because I'm not mutating this object. And instead, I'll cause the mutation on dcopy, and I'll return dcopy. So this will return the copy and not alter the original. So there we go. Whew. Okay. That's dictionaries in a nutshell. So I know there's a lot there. I don't expect, if you're a beginner, I don't expect that this class is going to give you a complete and thorough total understanding of everything that we covered with dictionaries. But this is, in a nutshell, the important things, the things to know to start with. And you can reference back to this and obviously talk to me, go through the material, kind of look for the concepts that we've covered. So this will definitely get you started. It usually takes people a few days, maybe a few weeks even, to really get a handle of dictionaries. They're the most complicated kind of built-in types. So if you struggle with them, you're definitely not alone. So I remember this being a lift when I was learning, for sure. Cool. So let's move on to tuples. Right here. Tuples. So the good news with tuples, we spent most of our time on dictionaries, but the good news with tuples is most of what you need to know with tuples you already know with lists. So let's just copy in this stuff. So tuples are ordered collections, so are lists. So ordered means they have an index. So no key, we're back to having an index like you're familiar with a list. So they're very similar to lists with 2 key differences. Tuples are like immutable lists. So everything we just talked about mutability, this whole question here is an exercise in exploring the idea of mutability, right? How do you pass this in without altering the original data? So tuples are immutable. So they don't have a copy method because they don't need to be copied. In fact, they only really have 2 methods. So let's IPython 3, and I'll say dir tuple. Look at that. Count and index. And it's good news because you know these from lists. Count and index, if you know how count and index works for lists, it's the same for tuples. It's the same for strings, by the way, as well. Strings have strings, tuples, and lists. All three have both of these methods, and they, in all three cases, they do not cause a mutation. They return a value, and they do the same things, right? So count gives you the ability to count the number of occurrences of some element. Index gives you the first index in which a certain element past occurs within a collection. So those are the only two methods we have for lists. Of course, we have the Dunder methods, but as usual, I'm going to just say don't worry about those. You can just ignore those for now. So we can index into tuples since they're ordered. We can index into the tuples, and it works just like you're familiar with a list. We can slice tuples, which works just the same as with a list. And yeah, there's the two methods, count and index. So they are very similar to lists, except that they are immutable. That's the big difference. This says that they're declared with parentheses. There are some places in Python where Python will treat something like a tuple that is not in parentheses. Let's just look at that really quick. Let's just make an empty tuple. I'll call this tup, empty tuple, parentheses. Nice and easy. So let's print tup. Surprise, surprise. It's going to be, we got to switch to the right tab. Okay. There's the empty tuple. No big shock there. If I print the type of tup, the type of tup is tuple. That was satisfying. All right. Cool. Who remembers what this is called? Don't worry about spelling it correctly. I'll take this question while y'all are thinking about this one. Is d.copy.items doing anything there, or is it just the same as d.items? d.copy.items means that so what I needed to do in order to fix this runtime error was to not iterate through the same object that I'm mutating. So I needed to distinguish between the two. So one way I solved that initially was by saying d.copy, which gave me a different version of the dictionary with the same values, with the same key value pairs, and then .items on that .copy to do .items so I could iterate through it with the for loop in the way that I'm used to. So that was the reasoning for that line. Cool. Yeah, and so this is called concatenation. And concatenation, I've gone through this CSI concept, concatenation, slicing, and indexing. These are very powerful tools. They're simple tools, and they're very powerful. Real quick here. Let's look at the dir for lists again. Okay, we'll come back to that in a second here. So this is one way to declare a tuple. If I want to put elements in it, we can do this. Oops. Append. I knew this was going to cause me a problem. We can do this. And notice this looks like a list, except it just has parentheses around it instead. Of course, slicing and indexing, I'm not even going to show those because they work exactly like you think they would for lists. So you already know those. We'll get into those in here in a second. Something that's really funny if you have a tuple with a single element in it, you can't just do this. If I do this, notice the value is 44. The reason is that parentheses are overloaded in Python. Overloading means they do multiple jobs. If I have in math, um, uh, 7 minus 3 times 10, right? So if I don't put these parentheses on, I'm going to get a different answer, right? Because 7 minus 3, or 3 times 10 takes priority over 7 minus 3, right? So this is going to be, the result of this is going to be 3 times 10, which is 30, 7 minus 30, which is, I don't know, honestly I can't do that in my head, but this is going to be 7 minus 3 times 10, which is going to be 40. So if I want to do 7 minus 3 first, I use parentheses. So parentheses, not only in math, but in general in Python, will help control your order of operations. It just defines some group of your code to be evaluated individually, and then use the result of that evaluation in the rest of the code, right? So parentheses have that job in addition to being the delimiter for tuples, which means that if you have a single element tuple and you just try to do this, the type of this, I mean, you can see it doesn't have parentheses, but the type, we'll just prove it, is an integer, right? Or if I say hello, right, it's going to be a string, right? So in order to have a single element tuple, you have to have a comma in it. So this is back to being a tuple. So it's a weird eccentricity that you just have to remember with tuples. So this says 55, just like that. Okay. So you know how to make an empty tuple, you know how to make a single element tuple, you know how to make a tuple with multiple things in it. What about if you want to add something to it? Well, remember what I said about it being mutable, immutable, and its only two methods are count and index. Count and index. There we go. Which don't have anything to do with changing the value. So I cannot alter the tuple itself. I can't cause a mutation to the tuple itself like I do with a list. However, concatenation, slicing, and indexing, I'm going to go through these really quickly, CSI, and I'm going to use these three tools to reconstruct most of the behavior from this. Now, in certain cases, it's going to be a little different, but it's not going to be a perfect one-to-one behavior reconstruction. Sort and reverse, well, sort, we can't do with concatenation, slicing, and indexing. We would either have to write a sorting function or just use the sorted built-in function, which I went over, which if you have a choice of which one of these to use, you should just use sorted anyways, so even for lists. For now, in my opinion. Okay, so append. So let's start with an empty tup. I'll just prove it's empty. Nothing in the tuple, nothing in here. And then we'll say tup. And this is why I asked about the concatenation thing. Tup plus, let's just say hello. We'll do hello there. Now this is a single element tuple like this. So I can concatenate to a tuple, I can concatenate to a string. You can actually concatenate to lists as well. Okay, so this gives me a tuple with hello in it. So what happens if I print tuple below that? Does tuple now have hello in it? So what's the value of tuple on line 168? Does it have hello in it or something else? What would it have in it? Go ahead and put it in Slack. And this, again, this is your intuition. I'm not looking for a right answer. I'm looking for your intuition. Cool, we got a couple empties. Yeah. So that's going to be empty. Great. So now I can do this thing, this kind of sneaky thing. It's not really that sneaky, but, you know. I can say tup equals tup plus hello. Now I can print tup, and now I've got hello in it, right? So I can do this again, and world, hello world. So this sure acts like an append, right? But it doesn't alter the type, it alters the identifier that's pointing at that value, right? So what I'm doing is I'm getting a transform and reassigning that transformed value into the identifier that was holding the prior value, right? And just as usual, oops, oh my gosh, used the wrong shortcut key there. Dang it. Sorry, let me just pull this back. My apologies. Okay, just as usual here, we have, when we have this, you know, A equals A plus something, we can do plus equals. So tup plus equals a single element tuple or tuple will give me that append behavior. This is great because this also, I'll put extend up here too. This covers extend and append because all I have to do is say, if I want to extend it with something else, I can say my name is Foo. Right, so this is like an append with a single element. This is like an extend, but this is, you know, just more a combination of them. Clear. Well, since we're just manipulating, since the whole name of this game is just manipulating the identifier. I mean, can you guess how to clear? Tup equals empty tup, pretty easy. Copy. Now, copy we can't imitate because we don't need to. Copy doesn't cause a mutation, but it's only useful in the context of having something that can be mutated. You know, if you can't cause the if you can't mutate the object in the first place, there's no point in copying it. Another way of thinking about this is any transform, and these are all what I would consider transforms. Any transform you perform on a tuple gives you an object with a different ID, so it's sort of a de facto copy. So you could, it's a little bit incorrect, I would say, to think about it this way, but you could think about tuples as being self-copying, right? So this is not necessary. Count, well, we just have a count method. Index, again, we have these two methods. We can just use these in the way that we normally would. Insert's a little funky, but essentially we can do the same thing. So let me do, we'll do this. Top equals this. And let's say I want to, let's say I just want this to say hello there world. So I want to insert there into here, the word there into here, right? So that's index 0, 1. Let's just say IDX equals 1. And sometimes this takes a little bit of kind of calibration, I think, about it. So a little bit of a guess and check will get you good on this one. If I say, first of all, print tup, and then I'll say tup equals tup, and I'll use a slice up to and including index, I think. Nope. Up to not including index, right? So that'll give me, this is 0, that's 1, so I want to go up to but not include index. Okay, so I'll concatenate that against a single element tuple with THERE, like this, and I'll do another slice, tup, and I'll start the slice at IDX and go to the end. And that's an insert. Pop. Well, pop does two things. So pop, the first thing pop does is returns a value. The second thing it does is it removes that value. So if I wanted to emulate a pop, I kind of have to do it in two steps. So let's say I want to pop off that there that I just added. We'll just do this. So I could say res is the result of usually what I say for results. So that's where I'm going to capture it. So I'll say first I'll say tup sub the index, when I'll do index equals 1 again. Tup sub IDX. I don't need to do that because I have index up here, but we're just pretending that this is a totally different part of the program, right? So I'll pop off at that index. So that lets me capture the value before I remove it. And then I'll do basically kind of a reverse insert. So all I need to do is let these overlap in some way, and this will require some calibration. So this will go from the beginning up to not including the value, and this will go from, I think I could just do minus from +1. Yeah, that's what it is, +1 here. Yep, there we go. So if I just add 1 to this, and there's probably different ways I could do this. I think I could also add 1 to here. Actually, that kind of makes more sense. So we'll do the stop inclusive. Oh, that duplicated it. So that totally backfired. So I guess I need to do -1 there. All right, so that's what I mean about calibration. Sometimes it's like hard to think through this stuff, but it's super easy to just guess a couple times and just figure out how you need to calibrate this. So this is kind of a pop, and it's a little clunky because we kind of got to do this in multiple steps, but it works. Remove, I could kind of use the, I guess, let's say, yeah, let's do something like this. Let's say I wanted to remove world. So again, that's at index 1, but I don't want to remove by the index, because that's the thing. Pop takes an index, but in this case, we don't know the index. And remove also doesn't give us back the value, right? So in this case, I'll call this element and set it equal to world. And we'll say tup dot index of world. Oops. I think that'll do it. Oops. Oh, I'm using a .idx. INDEX. I have to spell it right. And that'll remove world. So this is starting to get a little funky and a little bit clunky feeling. You could wrap this up in a function, and it would be pretty nice. Reverse is just going to be a reverse slice. So if I wanted to do a reverse, I could say tup ::(-1). Remember, we have our start, our stop, and our step. So if I take steps of -1 rather than +1, I just go in the opposite direction until I get from the end to the beginning again. So that is a de facto reverse. And then sort just uses the sorted function. So if we look through this, tuples are pretty powerful types, plus they have sort of the safety benefits of not needing to be copied. You don't have to worry about the data changing out from under you unless you put an equals sign somewhere, right? So if your tuple changes, it's because of something you did, whereas if if a list changes, you might be using a library from a different author that has a different opinion about mutability than you do, and you might hand over a list to some function that causes a mutation in a library that you never even seen or used, and so mutability is kind of out of your control in a way. You can do your best to control it, but there is sort of a sense of mutable types, powerful though they are, and certainly necessary as they are in computing, can be have some annoying kind of edges to need to be accommodated, right? So you need to know how to use mutable types responsibly. Whereas immutable types, you just kind of don't have to worry about them. So hopefully you can see tuples are pretty powerful. Cool. So we are out of time. We didn't get to sets. That's okay. I think that's the one that we can drop. Just a quick note. I will cover these. I will go over this. It won't be long. It'll be maybe 15, 20 minutes. I'll do this at the beginning of next class, or the next class that I teach. Essentially, what do you know about the keys in a dictionary? Imagine a data type that is only the keys in a dictionary. They're unordered. They contain unique elements. And I'll leave this as part of your homework. When you start working with sets, declare an empty set with this set function like this. You can cast a list to a set, so I recommend just using lists or tuples or whatever you're comfortable with, and then just casting them to sets. And then the 3 methods that I want you to focus on are going to be union, intersection, and difference. And like I said, I will cover these at the beginning of the next class that I teach. But yeah, you can kind of go learn through those. And maybe I'll go through these on in study hall on Friday. So I think I'll do that just to kind of make a little addendum here. All right. Cool. I release you. Y'all have a good rest of your evening. And I'll see you, I don't know next time I'm teaching. I think I'm teaching on Monday, but I'll see you around. And feel free to ask, to put in questions if you've got them. Yeah, you're welcome. You're welcome.